Hey guys, Mr. T here. This is doing another video on using tree diagrams to calculate that probability. So before, we've seen that tree diagrams are useful to represent sample space of experiments that have multiple steps and variables, so the more complex situations. So that allows us to find the probabilities of experiments with complex situations. If you assign probabilities to each of the branches of a tree diagram, then you can use those to find the probability of compound events. So let's do an example here. So Jack and Jill scoring shots. I assume it's basketball. Jack has a 4 out of 5 probability of scoring a shot. Jill has a 5 out of 6 probability of scoring a shot. Use a tree diagram to represent Jack taking a shot before Jill, and find A, the probability that both make the shot, B, the probability that Jack makes the shot but Jill misses, and C, the probability that neither make the shot. So we need to draw a tree diagram to represent this before we find the probabilities. So the two occurrences are that Jack shoots, so the Jack shot, and then we've got the Jill shot. So we've got the two possible events in the Jack shot, in or out. He either gets it in or it doesn't go in. So in, out. His chance of scoring a shot is 4 out of 5. Therefore, his chance of not scoring the shot, the complementary event to scoring the shot, is 1 out of 5. Okay? After Jack's taken his shot, Jill takes her shot, and there's two things that could happen. It could go in or it could go out. But Jack, he had two things that could happen. He could get it in or he could get it out as well. So we've done the branches for Jack getting the shot in and then Jill getting it in or out, but we haven't done the branches for when Jack misses and then Jill taking her shot. So in and then out. So what are the chances? Well, firstly, we need to check in our minds whether this is independent or dependent events. It doesn't say here that Jill is distracting Jack if he makes a shot or not. It doesn't say, it doesn't provide any other information, so we're assuming that these are independent events, that whether Jack scores or not, it has no effect on Jill scoring. So Jill's chance of making a shot is 5 out of 6. And therefore her chance of not making the shot is 1 out of 6. In, 5 out of 6. 1 out of 6. So now we can do probabilities. A, the probability that both make the shot. So we need to identify the path of branches that indicates they both made the shot. Jack needs to make the shot, so we care about this, in, and Jill needs to make the shot for both of them, so we care about that set of branches. So the probability both in is going to be, what's the probability of Jack getting it in? 4 over 5 times by the probability of Jill getting it in, 5 over 6. So 4 times by 5 is 20, 5 times by 6 is 30, 2/3 chance, therefore it's like 66.67% chance to 2 decimal points. B, the probability that Jack makes the shot but Jill misses. So I need to consider the branches here that fits with that outcome. So Jack makes the shot, so that's this again. But Jill misses, so it's not the top branch anymore. It's this bottom one for Jill's step. So now it's going to be probability Jack in, Jill out. That's going to be 4 out of 5 times by her chance of missing is 1 out of 6. So 4 times by 1 is 4. 5 times by 6 is 30. That cancels down to 2 over 15, but it doesn't cancel down anymore. So calculated time, 2 divided by 15 is 0.13 recurring, so it's going to be 0.13 recurring, therefore 13%, around about 13% chance of Jack getting in but Jill missing. And then C, the probability neither make the shot. So follow the branches where they miss. Jack misses along this branch here. Jill gets it in on the top branch there, so Jill missing is the bottom branch there. So the probability of Jack missing, easier way of writing that is just both out, is equal to 1/5 times by 1/6. 1 times 1 is 1, 5 times by 6 is 30. It's a 1/30th chance, 1 divided by 30, 0.03 to 2 decimal points, therefore 3% chance of that occurring. Okay, so that's just an example of using a tree diagram to model slightly more complicated scenario and also find the probabilities by tracking the branches that fit with the outcomes that you've stated you're interested in. Hopefully that helps you out, and I'll see you in the next video.